Hello. Welcome back to the channel. So, this is Project 2 Backups and Point in Time Recovery in Amazon Aurora MySQL. So, this is the project number 2, which we are going to see backups and point in time recovery in Amazon Aurora MySQL. So, in this project, we will focus on one of the most critical aspects of working with the databases in production, data protection, and recovery part. We will understand how Aurora backs up the data automatically and how we can recover from the accidental data loss. So the two important things what we are going to see here is how Aurora backups the data automatically and how we can recover from the accidental data loss. Let's move to the second slide. Before jumping into the demo, let's understand what we are going to learn in this project. First, we will learn what automated backups are in Amazon Aurora MySQL. Then we will understand how continuous incremental backups work behind the scenes. We will also learn what point in time recovery or PITR is and what is extremely important in real world systems. Finally, we will see how to verify backup retention settings in Aurora. In the second part of this project, we will focus more on the practical Spark push. We will simulate accidental data deletion, which is a very common production. Then we will restore an Aurora MySQL database to a specific timestamp using PITR. We will also understand why Aurora creates a new cluster during recovery instead of overwriting the existing one. And finally, we will validate the restored data and discuss real world production use cases of the PITR. This is the learning objectives we have discussed, and let's move ahead to the next slide. So now the question is how Aurora backups work. So what is the question? So the question here is how Aurora backups work. So Amazon Aurora continuously backups the data. So Amazon Aurora uses continuous incremental backups, which means only changes are backed up instead of full snapshots. So it is something like the changes which are made into the database, which is only stored and backed up. These backups are automatically stored in Amazon S3 and are highly durable. As we know that the S3 is the highly durable service, it is highly available. So the Aurora backups are stored in the Amazon S3 service. One important thing to note is that these backups do not impact database performance. So while the backup is going on, the database performance does not degrade it. So it is in turn managed by AWS. Using these backups, Aurora allows us to restore the database to any second, so within the backup retention window, which can be configured for up to 35 days. So these are the few things what we are seeing. So the first point is continuous incremental backups and stores in the Amazon S3, automatic, highly durable, and do not impact database performance. Restore the database to any second with backup retention window up to 35 days. Now we are going to do some practical stuff. Before doing that, as we are already created a Aurora cluster in the part one of this video, because we are using the same cluster. I will be recreating that cluster once again so that this um, everyone can follow this thing once again. So we will go to the AWS console. This is the Aurora console page, particularly RDS console page. And here we click on the database, which is Aurora MySQL compatible. Template would be dev and test. Database identifier is the name of the cluster. Aurora MySQL lab cluster. Username is admin, and the password would be we can auto generate it. So the cluster storage configuration is Aurora standard, and instances type is burstable instances with a T3 dot medium as the instance type, which includes 2 vCPUs and 4 GB of RAM. In the availability and durability, don't create any Aurora replica. Public access would be yes, so that we can test the functionality. And rest of the things would be as default. So, the database cluster is being created. As we know that Aurora works in the cluster format. So this particular cluster contains the once the cluster, another thing is the reader instance. So once it is created, we will see the connection details. This is the connection details, and this is the password. This is the username. So now we will open a client for our use case to see this thing. Let's open a client which is MySQL Workbench 8.0. To see this, this is the Workbench client. This is the older configuration. Let me edit the configuration, and we will update the cluster details. The username is admin. The password would be this one. And endpoint will also be changed. So just update the end. Click on test connection. Wait till this cluster is being created. Just refresh this thing. So still it is in the waiting state. We will need to wait till the the writer instance of the cluster is created, and then we can move ahead. just refresh this again till it is getting creating. So once it is in the available state, we can use this cluster for our application testing purpose. So for now, as mentioned in the slide, we will reach to this slide so that we have already covered in our previous video of the part one. In this part, we are going to test the backup functionality plus the data, how the data is recovered once any loss of data is happened. So it has gone into the configuring enhanced monitoring state. We will wait till it is available state. So once it reaches available state, we can move ahead with the testing portion. If you need to check the status, click on this refresh. It will refresh the status of the cluster which is configuring. It has gone into the modifying state, and after the modifying state, probably it will be in the available state. So this is the configuration process for any Aurora cluster. It is very easy. Just we need to provide the configuration format as we have seen, and we would be able to create this cluster. Now the next thing would be quite interesting part in which we are going to do some testing for first we will verify what are the backup settings that needs to be there. Then we will be putting some data into the RDS My Aurora cluster, and then we will delete one of the data entries and try to recover it back from the backup policy which we have already configured. Okay, now the cluster is completely in the available state. Now we are going to move ahead for the testing portion. Let's move ahead to the server configuration and test the connection. Okay, connection is tested successfully. Okay, we are inside the Aurora cluster and we just run this query once again. So this is the thing. Let's move to the slide to the next page. So we will verify the backup retention settings. Go to the cluster, go to the maintenance and backups. Now we can so this is the backup policy, and what we are need to check here is automated backup should be enabled and backup retention period should be 7 days. So automatic backups is enabled and its policy is set to 1 day, which is also fine. Now the next thing would be let's move to the next slide. So we will create a database which is called the lab, and we will create certain employees, and then we will verify the employees data, and finally we will test it by deleting one of the entries and try to recover it. So, before performing point in time recovery, we must confirm the automated backups are enabled that we have already done. So inside the cluster that we have gone to the maintenance and backup section, and then there is the automated backup settings that we need to enable and set the retention period as per the company's policy from 1 day to how many days you require. So this means that the Aurora can restore the database to any point in time within the last you can say that 1 day. Now the next thing is we are going to insert the sample data. So we will connect to the Aurora MySQL that we are on this page. So we create a database named lab and then create the employees table and then insert couple of records there. So let's create a new query. So first we will create a database called lab. First we will create a database called lab. Create database called lab. Okay, so the database lab is created. Now the next thing is we need to use this lab and create employees table. Create table employees. So first is the ID. So ID we need to mention here as int primary. The primary key. Then the name is varchar, which is of 100 characters. Let's create this table. Okay. So this table is created. Then we uh, then we insert into employees values, which is comma separated. Let's say that ID is 1 and name is John, comma, name is, let's put one more data. Then we run this query. If there is a mistake, is employees. We run this query once. Employees table is created. Then we run this query again. Then we run this query. So this is the response come out from the query. So this is select staff from the employees, and we are getting this data. So let me show you once again what I have done. So in this thing, first we have created the database called the lab. If you run this query, it will be created a database called the lab. Let me try once again and show it to you. Let's create a database called lab 2. So this is created. Then in the lab 2, create the employees table. The lab insert certain data. Then finally try to gather the data from the lab 2. Now, once we run the select query, we will get the data back from this. So this is the query which we have run. Let's move to the side window. So now we will be simulating accidental data deletion. So we are running this query at this particular time, and then we will restore it uh, from the restoration point of view. at what time we need to restore the data. So we go to the console. We create a new query and we'll use lab to what query you need to run. This is the query. The query is delete delete employees ID equal to this thing in the lab 2 from the employees table. We are deleting the query which is of ID 1. So when we run this query, so ID 1 is deleted. Let's try to run this query to fetch all the data. So now ID 1 is deleted, only 2 and 3 ID is there. What we have seen that till now. So what we have done, we have simulated a very common. So someone accidentally runs a delete command and removes critically data from the database. After running the delete command, we verify the table again and can see that one of the records is missing. This is exactly the type of situation where point in time recovery becomes extremely useful. We are running this query at this particular time of 11:50. We will try to restore it maybe a prior 11:49, maybe 1 minute before, so that we would be able to restore the data. So now the question here is how we can restore the data using point in time recovery. To recover the deleted data, we will now use point in time recovery from the RDS console. From the RDS console, we go to the Aurora cluster. Then on the actions, we will be going to restore to point in time. We select a particular timestamp before the delete operation, and we will be creating the new cluster as the identifier, and then the restoration would be start. Before moving ahead, let's quickly jump into the time of running this query. So the time of running the delete query is 11:51:59. So it is almost 11:52. So we will try to restore before this particular time of 11:51. Okay, so we can use the time of 11:51:00 to the restore point. Go to the AWS console, click on actions, go to point in time. So currently I am following the IST time. So it is we need to select. So it is showing latest restorable time is 11:53 that we don't want. We want custom date and time. We select today's date. Time is 11. It is in the UTC plus 5:30. So it is in IST time. And time would be 11:51:00. So this is the rest of the things would be as called. The only thing we need to provide here is the name of the identifier. So what we have done, what we are doing, so to recover the deleted data, we now use point in time recovery. So from the AWS console, select the Aurora cluster, then click on the actions and then choose the restore to point in time. We select a particular timestamp before the delete operation has started. Then we will provide the new identifier for identifier name for our cluster. So for example, our Aurora cluster name here is, this is the cluster name. We can provide the name as PI. This is the identifier as the name. Then we will click on restore to point in time. So we will wait till this point in time cluster is being created. It will be creating the data. Till it is being created, let's move to the slide. So, so it is very important to understand that Aurora does not override the existing during PITR process. So the existing cluster is intact, and the new cluster which is getting created, so it will be putting the data, the restored data to that particular cluster. So it is just not like that it is updating the current cluster. It creates the new Aurora cluster with the data restored to the selected timestamp. This approach ensures the data safety. So what it ensures? It ensures the data safety, allows validation before switching the applications, and avoid any risk to the original databases. So these are the few things which you can count into why the Aurora creates the new cluster during the restoration of the data. It is the general behavior of the RDS when we restore any data. So it creates a new Aurora cluster with the data restored to the selected timestamp. This approach ensures the data safety, allows validation before switching applications, and avoids any risk to the original database. Finally, once the cluster is ready, let's see whether the cluster is ready or not. Still, it is in creating state, so we need to refresh this thing. Once it is in the available state, we will be validating the stored data. So it will be taking some time, like 5 minutes or more, to create the restored PITR cluster. It is just one of the features of the Amazon Aurora to recover the data, and anyone can use it. It is easy to use directly. We can create the restore the data. So data recovery is something like we are how much data we are willing to recover. That is the additional feature of the Amazon Aurora. So we will be waiting till it is in the available state, and finally after this thing we will be going with the testing portion. So Now we will validate the restored data. So once the restored cluster becomes available, let's check this thing. So once the cluster is in the available state, as we can see that that PITR cluster is in the available state, we will run the same select query on the employees table and try to see the PITR has successfully recovered the data or not. This is my old connection. Let's connect to the database using the PITR connection, which has newly created, which I create the new connection, and in this I use the endpoint which is created by the PITR cluster. Then we click on OK. Okay, PITR connection is created. We need to use lab2 as the database and then select star from employees table. We need to run this query. If you are seeing this workbench screen, particularly we need to use the lab2 and then select star from the employees. Let's run this query. So still we can see that it is not restored properly. Let's see why it is not restored. Check with the lab is coming fine, but the lab 2 is still showing the name. So I think I'm the connections page, the PITR to update the newly created cluster endpoint details. Okay, so I think this particular workbench is not working properly. So we need to give it one more try if it is not working. But this is the complete process that we have discussed. So it is not letting me. Okay. Then we start the workbench. We try to open this thing. I think there is some issue with the restoration point of view. Okay, no, we need to check it later maybe. I think the cluster which is created with the wrong configuration of the timestamp. We need to verify it once more. So let's move ahead and we will verify this thing later why it is not restored, but the portion how we have verified this thing, that particular thing is the same. We are going to follow the same process. We go back to the actions and point in time recovery, and then we will try to recover to this particular point. There could be some issue with the timestamp when that delete operation happens. So this could be the behavior. So we need to exactly know the time before the delete operation has occurred, and then we need to run this query, and then it would be better. So moving forward, let's summarize this project. So let's summarize what we learned in this project. We understood how automated backups work in Amazon Aurora. We verified backup retention settings. We simulated accidental data deletion. We restored the data using point in time recovery, and finally validated the restored data. That validation part I can't able to show because of that restoration point issue, but yeah, we will show them in the upcoming things when we try to recreate this cluster once again. So, what's next? In the next project, 3, we will learn about the Aurora reader instances and reading scalability, how we can scale the scalability of the Aurora cluster. We will understand how Aurora handles high read traffic and how read replicas improve the performance and availability. Read replicas are those features of the of any RDS Aurora cluster which helps in read functionality, not the write. It helps in read functionality of the database cluster. Okay, yeah, so this marks the ends of this video. We will get back to you with the part 3 as soon as possible. Thank you for watching this video.